So example 3, verify the identity. Again, the 11 through whatever the rest of the section is, they're going to say verify the identity. They'll all be identities. So only the first 10 do you really have to type the stuff in your calculator and verify whether or not they are. All right. Once the number 11 happens, everything from that point forward will be an identity. They'll be true. You have to prove that they are. So the left-hand side, the right-hand side in this case look pretty much exactly the same, right? So I can take either one. I'm going to take the right-hand side just because I keep on wanting to call it the right-hand side. So 2 cosine squared of x minus 1. That's the right-hand side. Okay, and again, my goal is to get it to look like the left-hand side. And first thing I want to bring to your attention about these trigonometric identities is every one of them has a trig function squared. So if you see a trig function squared on your paper and you have nothing else to do, in other words, I'm simplified. That's simplified. That's very nice looking. All right, I can't make that any prettier than that. There's no. I suppose there's some factor. Well, no, because that's not a perfect square. Yes, it's not factorable really easily. I mean, I could put a square root of 2 as a, 2 is the square root of 2 squared. But it's pretty well simplified. So when you have something simplified but you see a trig function squared, focus on those trigonometric identities, or so Pythagorean identities, numbers 5 through 13. All right. What I notice is that cosine squared is equal to 1 minus sine squared. That's a fact. The other option I have is that 1 is equal to sine squared plus cosine squared. Both of those right there will help me change this from what it is to something else. I can change this 1 into this binomial. If I do that, it's minus the whole thing, right? Or I can change the cosine squared into 1 minus sine squared. What do you guys want to do?
1 minus sine squared.
You want to go with this one, all right? And that's number 6 or 7? Number 6? All right, so I'm going to change cosine. Oh, 7. Okay, so I'm going to be modifying. So I'm going to change cosine squared into 1 minus sine squared. I'm replacing one object with multiple objects, right? So that requires parentheses. So 2 times 1 minus sine squared of x minus 1, and that's by number 7. All right. Now, if I simplify this, distributive property, right? 2 times this, 2 times this, and that's it. So I get 2 minus 2 sine squared of x minus 1. All right, and that's just the distributive property. And then notice that 2 minus 1 makes 1, right? That's just add like terms. And notice 1 minus 2 sine squared is the left-hand side. We went from the right-hand side to the left-hand side, so we successfully modified it. All right. And again, that's a correct way of doing it. Had I gone with this one instead, I would go with that one personally. But had I gone with this one instead, watch what happens. 2 cosine squared of x minus, and then I'm changing this to sine squared plus cosine squared, right? And if I distribute the minus sign there, that's going to get me 2 cosine squared minus cosine squared means cosine squared minus sine squared. I can see that I want to get just sine squared, so the fact that there's a cosine squared there tells me, hey, maybe I don't want that in there. So then I'd probably want to change this to 1 minus sine squared minus sine squared. There's 2 sine squareds. It's not wrong. A little bit more involved. But again, the fact is there's more than one way to get there. This is correct, I think, if you have all your stuff. So we have substitution with number 5. Simplified distributive property, add like terms, and then of course we have substitute number 7, and then add like terms. So again, it's the same type of process, it's just a little bit more complicated. Will you find the most efficient way to get the answer every time? Probably not. Find me a way to get there, do it correctly, don't break any rules of algebra, do proper substitutions, and you'll have a proper answer on these.